Yay. So, you had this homework to look over. Was it a lot of fun? We can do the hand vote here. What do we think? 5 is awesome. 0 is it was the worst thing ever. So what do you think? Awesome or 0? What do we think here? Not bad. We're getting 4s and 3s. A-okay? Something like that. 3 or A-okay? Is that a 6? A little bit of both. So we have a new vote here. Okay, we have a vote like that. That means, awesome. Okay, 5. What does that mean? Like, super awesome? I don't know. I'm going to delete these right now. Okay. So it's decent, okay? You thought this was okay? What do you think about the tone of the questions? Are they nice? I kind of like this material. We're going to use hands here. You're going to raise a hand, and then I'll call on you. It's amazing. I say that out loud, and then the first thing people do is just say something out loud. I want to call on you, then you'll speak, okay? We'll alternate between free form and hands. Which one do you want to talk about? Which one are you most concerned about? Yeah. Number 16D. Oh, wow. You guys started the exact same way the other class did, which is good because they have no sound on their recording. So we can just do all the same ones again. I mean, at first it sounded a little redundant doing 3 of the same class a day, but this helps. Okay. So X is the horizontal distance traveled. So the horizontal distance is always growing, right? It's always getting bigger. So A is going to go up. You might get something like this. And I'm going to do rough sketches here. It's going to go up, 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 up. It's going to slow down when it's landing, right? And it stops, right? Does the horizontal distance ever go back to 0? No, because the plane's going somewhere. If it ended back at 0, it meant it landed where it started. Yeah. So B asks you, what is B? Y is the altitude of this thing. Let's do the same graph here. If this is A, altitude, what does it do? It goes up, it levels off, right? Then it goes down. Something like that, right? Goes up, levels off, and goes down. Sketch the possible graph of the ground speed. This thing speeds up, right? And then what does it do? These are all different units. I'm doing it on the same graph, but the y-axis is different units on each of these colors, right? Some of it's miles per hour, some of it's altitude, feet, meters, whatever, right? So this is just a rough sketch. The time is the same, though, right? So what is this thing going to do for ground speed? It's going to get to a certain speed, stay with it, right? And then go down again. Do you agree? I mean, the curvature might be different, but while it's cruising, it's going to stay the same, and then it's going to slow down. Is that correct? Now, the trickier one, though, is I'm going to draw this one. Definitely D is the trickiest one. Vertical velocity. What does vertical velocity mean? Can someone raise their hand and tell me what does vertical velocity mean? The speed of rising, right? The speed of rising. So a really big positive vertical velocity means the object is going upward really quickly, right? So at the beginning, what's the vertical velocity going to be? It's 0, right? It hasn't taken off yet, right? Hasn't taken off, and then what's it going to do? It's going to be rising, it's going to be rising. Is it always rising? No, what does the plane do? It gets to what's it called when the constant altitude, right? What's that called? It's called the cruising altitude. When a plane is traveling, is the plane always going up and then goes down? Like, does a plane do this when it goes somewhere? No, it goes up, goes straight, and then goes down. So when it gets to cruising altitude, is it moving up or down? It's not. Thank you. It's not. So it gets to cruising altitude, but it's rising. This right here represents while it's at cruising altitude. It's rising, and then it slows down, and it gets to cruising altitude. So what does this represent right here? Actually, we'll do this in 4 parts. What does this represent right here, the purple? Take off. It hasn't gone off the ground yet, right? What does the green represent? Rising. And what does the yellow represent? While cruising. Okay, so let's look at this. Now it starts to fall. What's the vertical velocity going to be if it falls? It's going to be negative. So it's going to go down, and then when it hits the tarmac, is it going up or down? It's not. So what is this going to look like? Pretty much in reverse. It's going to look like that. So what does this represent right here? What does that represent, the blue? Yeah, descent. or landing, or falling. Yeah, falling is kind of a bad word to use for an airplane. And then let's use pink again. What's this represent right here? Maybe taxiing to gate. Does that make sense, everybody? Velocity can be negative. Can speed be negative? What class taught you that? Physics. Speed. What do you know about speed? Can't be negative. Exactly. Good. What's another one you want to talk about? What's another one? Someone raise their hand and then ask. What one do you want to talk about? I have one I'd like to talk about, but Bjorn, what do you want to talk about? What number? Oh, that's amazing! It really is in that order. What was the last class? I'm not kidding. It actually was. Number 8. This is a neat question. It's asking you what? Is it a function and what's the domain and range, right? Let's take a poll. Who thinks this is a function? Raise your hand if you think this is a function. It seems like it's a function then. We're kind of crowdsourcing the answer. It means you get extreme. It's either really right or really wrong. Is this a function? We think it is. Claire, can you tell me why it's a function?
Well, I did like each of the 2 different sections differently and did different domain and range.
You could, but I'm saying, is this overall, is this a function? Overall. It is. Can someone explain why it's a function? We have one test to see if it's a function. What is it? Yeah, there's no vertical line that passes through more than 1 point. Is there any vertical line on there? No. It looks like there might be one right here. Oh, that's a bad highlighting. But does that pass through more than one? No, it only passes through one because it's a closed dot and a open dot, right? So this is a function. Can someone tell me carefully what is the domain of this function? Raise your hand. Someone tell me what the domain of this function is. Yeah.
-3 to +2.
And does it contain -3? Yep.
Yes.
It does, because they're closed dots. You could say x is greater than or equal to -3 and less than or equal to 2. Now here's the fun one. Can someone tell me what the range of this function is? What are the y values of this function? Look at it sideways. Just tell me, what's the range? What's the lowest y value? We can agree it's a -2. Absolutely. It is definitely -2. What's the highest one? The highest one is 3. And it does contain -2 and it does contain 3. It's what's in between that has to matter. Look at this sideways. What y values does it cover? What y values does it cover?
0.
Does it contain 0? No, but how close does it get to 0? Extremely close. Does it get to 3? Yeah, so it contains everything between 0 and 3, but not 0, and it does contain 3. What about over here? Is there anything else over here? No, there's a big gap, right? Is there any value between -2 and 0 that this contains? No. So how do you write this? That was the big question. You can write it a few ways. This is how I'd like you to write it. -2 union 0 to 3. What does union mean? You just put them together. You just put them together into one set. If you're in doubt as to how to write it, but you understand in your head what you want to write, what can you always write? Write in words, right? Sure. Just to review set notation a little bit, let's say I had the set -3 to 5, and I wanted to union it with -1 to 7. If you union those two sets, what do you end up with? If you add those two sets together, what do you get? Well, this one's from -3 all the way to 5, and this goes from -1 to 7. So if you add them together, what's your set? -3 to 7. Let's say I wanted -3, 5 intersection -1 to 7. What do you end up with? To 5. Does that make sense? Yes. And with that, go to lunch. Piecewise defined functions. We've already talked about them a bit. Can someone give me what they think is the simplest simplest definition of a piecewise defined function, the simplest thing they can think of? What is a piecewise defined function? What's the definition of a piecewise defined function? Well, the name gives you some pretty big hints. Yeah.
A group of functions with limits put together into one equation.
You're putting a bunch of functions together into one equation. That's true. I'll make it simpler for you. It's a function defined in... there we go. I know you're really not supposed to use what you're trying to define in the definition. So, more correctly stated, a function defined by different formulas in different parts of their domain. So, I'll put that in there. And the function below that is a piecewise defined function. It's defined by different formulas in different parts of their domain. So that's what they are. So these are just pieces of functions that you've already seen before, grouped together to make a nice pretty picture. Could you graph 1 minus x? How confident are you that you could graph 1 minus x? Pretty confident? Let's go back to random note cards here. I like that. That's fun. Lawler, what's the slope of that line?
1 minus x. -1.
Yeah. What's the y-intercept? Hold on. Oh, you get it. It's 1. That's fine. So it's 1. Okay, so it's at 1, and it's got a slope of -1, so it kind of extends like this, right? But we only want it when what? We only want it when, we only want that function when what? So where's x equal to 1? X is equal to 1 right here. Oh, and that's a poor line. Got to work on my line drawing, huh? So that right there is x is equal to 1. So we want it when it's less than or equal to it. So we draw open or closed dot right there. Closed. And what do we do with everything to the right? We want everything gone here because we only want stuff that's where x is. This is where x is less than or equal to 1. X squared. Does that go through the origin? Yeah, it does. What's another good point that goes through? 1, 1. Where else does it go through? 2 what? 2, 4. It's squares, right? It goes back the other way too. So it goes up like this, and it also goes up like that. But we want it only when what? X is greater than 1. So do we want an open or closed dot? We're looking for an open dot at that boundary. Oh, let me change that back. So we want to get rid of this, right? Get rid of that open dot right there. So this is definitely an open dot right there, and that's definitely a closed dot right below it. So what are other things we could label on here? What are other things we could label to communicate this more accurately? What's one other thing we could label, Ethan? What's one other thing we could label? Absolutely, that's great. So this is y equals x squared, and this is? Yep, sure.
Would you want us to, like...
What else could we label? What else could we label?
Well...
Yeah?
But, like, would you want us to shade it, or is that...
There's no shading involved in this. There's no shading. What else could we label? There's something else we could label, yeah.
Units?
Could label the units, absolutely. With the 2, 4, 6, -2, -4. Sure. What else could we label? We could. We kind of did already. We could figure out the domain and range if we wanted to. What's the domain of this function? The whole thing. What's the domain of this whole function? What'd you say? Someone said it. It's all real numbers. Is there anything you can't plug in? Are there any gaps? No. What's the range? Yep. Yeah. Y greater than or equal to 0. Can y be negative? Nope. So again, what else could I label on here? There's something else I could label that's not there. Yeah, we could say x, sure. Y-axis. What else? What else can we label? The x-intercept. Another way to say that, we could take that and say that's 1, 0. What else could we label? You could label, I'm sorry, what? Yeah, you could label this. That's what I was looking for. That's 1, 1, right? It's really important. Label important points. So when you're graphing piecewise functions, label important points. Label functions. Label axes. Put in appropriate arrows. Basically, it comes down to this. Do not be lazy. I see a lot of like, I don't want an interpretive, Rorschach blot, right? I want something that's concrete and labeled. I don't care about what it makes you feel. I'd like you to communicate to me something clear. Does that make sense, everybody? It literally would take you about 5 more seconds to sometimes make your graphs look way better. Buy a ruler. They're like 20 cents over at the dollar store or less. Get one. Use it. It's fantastic. If you label all of these things, it'd be happy. Even if it's clear, even if it's really obvious which one is which, what happens if you got one of them wrong? What happens if you graphed it in the wrong place, but you labeled it correctly? It's easier for me to do what, as the teacher? Correct it. Maybe figure out what you were trying to do. Make it as less guessing and more, oh, okay, if we just, the slope is inverted, right? That's fun. I think it's pretty fun. You need to do 2 things for me, though. You need to be able to do 2 things. So first of all, we've talked about open and closed dots, understand the notation. What about absolute value functions? Does everybody know what an absolute value is? Here's the big kid definition of absolute value. The absolute value of A is A if what? If A is positive or 0. The absolute value of A is the opposite of A if A is negative. So the graph, you've all done this before. F of x is equal to the absolute value of x. How do you graph that? What is that function? What type of function is that? We just put it up. What's the word? What type of function is it? It's a piecewise defined function, right? How is it defined? It's defined in how many pieces? 2 pieces. So on the right-hand side, what's the function? It's y equals x. And it includes that because what's the absolute value of 0? 0. What about the left-hand side? Y equals negative x. That's where x is less than 0. And this is where x is greater than or equal to 0, right? So you've already seen a piecewise function before. All absolute value functions are going to have some sort of v in them, for the most part, unless you do some very weird things to them. Like, if I only look at this part of the function, is there a v? No. But if I look at the whole domain, is there a v? Yes. Can you flip this over? How would you flip this upside down? Well, what does this look like? Can you tell me what shape that looks like? What's that called? This is a parabola. How would you get that parabola? Does that face up or down? How would you get that parabola to face down? Yeah, y equals negative x squared is face down. So if I wanted an upside down v, it would be y equals what? Negative absolute value of x. What's that graph look like? It faces down. But is it still a v? Yeah, the shape, the overall shape. This is called an isometry. The important structures stay the same. Like if you stand there and I move you somewhere else, you haven't changed. Your orientation has. But if I took your arm and stretched it out, well, it's also an isometry, so we'll rewind on that. But if I broke your arm off, this is getting graphic. If I broke your arm off, that is no longer an isometry. That's not good. Okay. Anyway, that's right. I just worked in dismemberment into math class. You need to be able to do 2 important things with piecewise functions. You need to be able to go from the function to the graph. That's the first thing you need to do. So, for example, let's say I gave you this. Please graph that for me as carefully as you can. Graph this. No, not this. Graph h of x in as much detail as you can. Please do that for me. So you have to be careful. We'll do a rough sketch. We know that the parabola goes like this. And I'm going to draw a poor parabola, I'm sorry. We know it. And are they closed dots or open dots on this parabola?
One is closed.
Yeah, it's closed over here, but on the other side, what is it? It's open. And what are those points? This is 4, -10, and this one is -10. And then you have -x minus 4. -x minus 4. Is it a closed or open dot right there? It is a closed dot. This is the same. What is that? That's -4, 0. And the other one is -x plus 4. Where's 4 going to be? It's, I don't know, right about here. Is this really to scale? Am I drawing this thing to scale? Not really. But you get the idea here. This is going to go like this. And is it an open or a closed dot? It's an open dot right there. And it goes like that. So let's edit this a little bit. So what do you think of this picture? How did I do? How did I do? Did I do pretty good or bad? What's that point right there? You need to figure out what that point is, right? What is that point going to be? Oh, wait. It should be exactly where? It should be at 4, 0. So I didn't do a very good job, did I? So where should it be? We'll say that's 4. It's not really negative slope right there. I got to go back to this eraser. So what does it actually look like? It looks like... So what is that coordinate right there? And what's this equation? Y equals -x plus 4. This is y equals -x minus 4. And then this function is y equals -x squared plus... What's the domain of this function? What's the domain? What's the smallest x value? What's the smallest x value this thing could be? The whole function. There is none. So what's the domain of this function? All real numbers. What's the range of this function? What's the smallest y value, kids? What's the largest y value? Does it skip over any? No. So what's the range? All real numbers. Doesn't skip anything. It covers the entire x-axis, covers the entire y-axis. Every y value is represented and every x value is represented. Cool? Yeah? So one more thing you need to be able to do, and you're going to have to do this on your homework, is this. We just went from a function to a graph. What else do you need to do? You need to be able to do from a graph to a function. So the bell's going to ring in a second. Just stick with me for 1 minute. Let's say I gave you this. Let's say I gave you a function that looked like this. Let's say that's -1, 0 right there. -2, 3. Let's say that was the line segment. And then let's say the vertex of this parabola was here at 2. Say it went down like that. So that's 1, 1. That's 0, 2. And this is... Oh, and that's not a function, is it? It's opened up right there. Just wait a second here, kids. Could you come up with the equation for each of those? Well, one's a line and one's a parabola. What's the domain of the red? X. What's it less than? -1. And what's it greater than? -2. What about the gray here? X greater than what? Negative what? -1. It's -1, right? So we had the domain. Could you come up with the equations? Yeah, you're going to have to do that for homework. It's exciting. So what you're going from this picture to what? You're going to the piecewise function. You have to. How many pieces are there? Your homework tonight is from your packet. It is right here. Don't open the door quite yet. They can wait. Your homework is right there. Right there.